All attendees are in listen-only mode.
Good evening, everyone. This is Shane Gebauer. I'm the General Manager of BrushyMtnBeeFarm. I'd like to welcome you all here this evening to discuss hive health, maintaining a healthy hive. I'm going to try and keep this a little fresh and not simply rehash a lot of the same topics and issues that we've talked about in the past, but inevitably we'll get into that. And so let's dive in here this evening and see what it means to maintain a healthy hive. So ideally, right, we look for something like this, a nice frame of brood. We've got some honey up in the corners. We can see some pollen around here. We've got an open patch in the center. Presumably that's from some of the older brood emerging, and now hopefully the queen will be coming back through and relaying, but this is a fairly nice, healthy-looking frame. There's a few empty cells, but otherwise looking pretty good. If we zoom in on a frame, you know, something like this, a good brood pattern, nice, healthy, white larva of mixed age here. We see some reflection of light off the nectar or honey that's in the cells here, as well as some capped honey that the bees can utilize for resources to feed the developing population, the future generation of these bees. We've got some good nutrition, a couple of cells there of pollen, not quite as much as we'd like to see, but still just a whisker of pollen. And also what we'd like to see is hives stacked up looking as high as these, 2 deep brood chambers with 4 medium supers stacked on top, undoubtedly plugged full of honey that will be harvested. So this is sort of our goal, right? A good, strong, healthy, robust population that can maximize on the honey flow, the nectar flow, and produce a good quantity of honey for us that we can extract for our purposes. And so what do we have to do to get to that point? What do we have to do to maintain a healthy hive? We need to focus on, in my opinion, these 4 things. Diseases and pests. We need to look at nutrition. We need to look at contaminants. And of course, ultimately, the quality of the queen is going to dictate the overall strength of that colony as well. If the queen isn't worth much, then of course the colony population is going to suffer either from disease or just simply due to lack of numbers. So these are the 4 things that we're going to hit on here this evening. Let's first talk about disease and pests. We have to talk a little bit about Varroa. I said that I wanted to keep this fresh and not simply rehash some topics. Varroa is one of those that I don't want to rehash. I'm sure if you've been to meetings or association meetings or regional, etc., that Varroa has been talked about to death. You've been beaten over the head with Varroa. And there's good reason for that, and we'll talk a little bit about that, but I want to try and bring a fresh spin to this. So first, a little bit about the life cycle. Of course, we know that the mites go into the cell with the developing larva. They get sealed in there. They reproduce in that capped cell with the developing bee, and when the adult bee emerges out, only the sexually reproductively mature female mites leave, and so on average about 1.8 mites for a worker cell and 2.7 mites for a drone cell. And the reason for a little bit more from a drone, of course, is that cell, that bee takes 3 extra days to mature, so it's capped just a little bit longer, giving that the mite a little bit longer to reproduce. And so what I'd like to do here, before we get into too much of this, I have a poll question that I'd like to launch real quick. Let me go ahead and launch this. And the question is, when do you typically treat for Varroa? And I've got some months listed there: July, August, September, October, and then never. And I want to broaden the definition of treat. We can think of treatment as the hard chemicals that you may have seen, things like Apistan, Apivar, Checkmate, etc. We may also think of treatments as soft chemicals, the Apilifar, which is thymol-based, the Mitoway Quick Strip, which is formic-based. We can also broaden our treatments to things like powdered sugar. That might be a little trickier. You can't pigeonhole that into a particular month, but hopefully we can get a sense here. So I'm going to go ahead and close this poll here, and if you could respond in 5, 4, 3, 2, 1. I'm going to go ahead and close this poll, and I'll show you the results real quickly so you can see that. Okay, that should be up on your screen. So the majority in September and tied for August and never with 26%. Some of you in July, some of you in October. So that's great. Let me go ahead and hide that here so I can go back to what I was discussing. So that's some good information, and that'll hopefully be relevant here in the next couple of slides. So let's talk about Varroa and hive health. Of course, the direct consequence of Varroa going into the capped cell or into the cell and being capped over with the developing bee is of dire consequence to the colony. You've got these mites parasitizing the bees, sucking their hemolymph, their bee blood in there, developing with the bee itself. That, of course, has an impact on the overall health of that particular bee and therefore the colony. But what I want to try and emphasize here this evening is sort of the indirect consequence of Varroa, and that is the viruses which they vector. So you've got things like deformed wing virus, which many of you probably have seen at some point, where the wings of the bees are shriveled up. They look sort of like spaghetti noodles. They're obviously not functional wings. Things like Israeli acute paralysis virus, chronic bee paralysis. And there's several others that these mites are transmitting to the bees, or these viruses are prevalent or present in the colony, and the presence of the mites therefore weaken the bees to the point where these viruses are able to take hold. So we've got the vectoring of viruses. So this is very analogous to the mosquito and malaria or West Nile virus, that you've got a mosquito sucking your blood. Of course, you swat at it, you kill the mosquito, and you think, great, my pest is gone. But really what's happened now is you've been infected with malaria, West Nile virus, whatever the case may be. So it's that secondary consequence of the pest itself that is really impacting us or the colonies. So just because you treat and you kill your mites, and you never get 100% efficacy with any treatment, but just because you knock the mite population down does not mean that you've got a good healthy hive again. Elimination of mites does not equal a healthy hive. And we need to sort of shake that mindset that I think is prevalent in a lot of beekeepers that treat the mites, kill the mites, healthy hive. We need to think about it a little bit differently, because the mites are weakening the immune system. These viruses, of course, are taking its toll on the bee's immune system and causing problems. And so just because you knock the mites down does not mean that you've got a healthy colony going into winter. And that's really the challenge, right, is getting your colony healthy to overwinter. So here's some Varroa. You can see the Varroa on the backs of these bees. There's 2 on each bee. And you can see these shriveled up wings. This is a picture of deformed wing virus. And so this deformed wing virus is vectored by the mites. So how do we know whether we've got a mite population? Here are some methods and crude numbers to use as a threshold. These are just generalizations. They are not absolute. Certainly a lower population, regardless of time of year, is much better than having it get too high, because what happens as the bees and mite population increases, so this is from Scientific Beekeeping, as the bee population increases, here at a maximum roughly in June, the mite population lags behind, because the reproduction of mites is linked to the reproduction of bees, but they're offset slightly. So we see the mite population hitting its maximum in August/September, thereabouts. And what we would also see if we had the virus loads plotted on here is that they too would lag behind the mites. That, again, going back to that analogy of if you just get bitten by a mosquito, you are not instantaneously feeling the effects and exhibiting the symptoms of the virus that mosquito has transmitted. Just the way the bees are not instantaneously exhibiting the symptoms of the viruses that these mites have vectored. And so there's that sort of delayed in where we see the population of virus loads hitting its maximum, a delay in when we start to see some of the symptoms of these viruses. And now, if we use this graph and look at this graph and think about the poll question that I asked earlier about when you treat your bees, or this has some relevance. And I'm glad to see that there were so many people in July and August, because if you wait until this point right here, let's say you wait until September, well, that's about when the bees are hitting, or I'm sorry, the mites are hitting their maximum. And let's say you're using one of the traditional hard chemicals, which have about a 45-day treatment period. If you start, say, mid-September, after the goldenrod flow has come and gone and maximized on your honey, you're not going to see that treatment finish until the end of October, which means your mite population will not be sort of brought down to a healthy level until the end of October. And now what you've got is that sort of delayed response of the viruses that are going to persist beyond that time, say into late October, early November, before their levels start diminishing. Well, at that point, that colony has already made the bees, they've already raised the bees that will form the winter cluster that you're expecting, that you're hoping will carry the colony through winter. Well, if they've already raised those bees and they are already heavily infested with viruses, you could have a booming population in terms of numbers, but all those bees are not healthy. And so what happens is that population decreases drastically as winter sets in and the conditions become harsh. The stress is on those bees are increased by cold temperatures, by starvation perhaps, because they're not able to move to honey, by temperature fluctuations that cause problems with moisture in that hive. Whatever the case may be, those bees are already stressed by viruses, and any additional stress is going to shrink that population quickly to the point where it probably will not survive winter and probably will not carry it through until spring, when those stresses are mitigated by nectar flows, favorable weather to start replenishing the natural mortality that of the bees that occur during winter, and so you're going to see a death. And to give you some indication, this is kind of complex and a little heady, but it's a good illustration on these viruses, because basically all the long or the short of this graph is that you've got a drone here and it mates with a queen, and the queen lays eggs, and these bees, of course the egg develops into worker bees. So this is viruses being transmitted in what they call vertical transmission. It's going from the queen to egg to larva to bee. But then you've also got these horizontal transmissions, where the bees are actually spreading it to other bees. And so you've got the activation, so to speak, of and vectoring of these viruses from the varroa mites. And now, once those viruses are present and at high levels, you see the transmission of these viruses sort of being perpetuated within the colony through the queen and also through the other bees. And that's why one of the reasons why there's such a latency period where these viruses persist after varroa treatment. So we need to start thinking about treating our colonies earlier rather than later. So those of you that are doing July and August, kudos. For those of you that answered later in the season, we need to think about moving it up so that we have healthy bees going into winter. And that means decreasing the Varroa population, therefore decreasing the virus threshold, the virus levels in advance of winter, so that colony has an opportunity to raise a few generations of bees under low mite, low virus levels, so you do truly have a good, healthy population going into winter. Not just simply in numbers, but in actual health as well. So you've got this horizontal and vertical transmission, the long latency period, and there was this next bullet point, Martin in 2001. This is a mathematical model, which, as beekeepers, we know sort of laboratory mathematical models don't always translate into real world application, but it still illustrates a very important point that just 8 mites per 300 bees was sufficient based on this model to have a viral epidemic which collapsed the colony. So that gives you some indication of sort of the severity of this problem. And here is another example that looks at colony strength and its ability to deal with Varroa and virus. In this case, it was the acute Israeli acute paralysis virus that they were looking at. So they have strong colonies, they've got weak colonies, they've got infestation levels with Varroa, 0 Varroa, 10%, 20%, 30%, and this is days after Varroa infestation, where they tested the amount of Israeli acute paralysis virus. You can see, of course, with the higher infestation rate in these strong colonies, you did see an increase in the virus. But this is, look at this. So you've got a weak colony now, and it's weak for maybe because it's a failing queen. Maybe it's got poor nutrition. Whatever the case may be, it's weakened. And now look at the difference between the virus levels in just a 10% infestation rate and a 30% infestation rate. So you can see that it's important, it's really important, not only to treat for Varroa, but also keep those Varroa levels from getting out of hand. So doing things mid-season, things like maybe throwing in a couple powdered sugar occasionally to try and shake off some of the phoretic mites, the mites that are on the external bees in the colony. You're not going to touch the ones that are under the caps, but you're just trying to keep that Varroa population lower so that you don't see this sort of tremendous growth, this exponential growth of virus levels because your Varroa population is getting too high. So not only do you have to treat earlier, but you also have to take measures to maintain that the levels at a low percentage of infestation. So we need to think about keeping doing something during the growing season when we're collecting honey to keep that Varroa level low so our viruses don't increase as well. And some options would be the integrated pest management. Break the brood cycle. You can cage a queen. I'm not a big fan of that, but one of the best ways to break the brood cycle is to split a colony or to requeen a colony. Because if you split it, of course, there's an introduction period where you're introducing a new queen or a cell or whatever the case may be, that colony is going to be without fresh eggs because the queen's being introduced. Therefore, there's going to create a break in the reproduction of the bees, therefore a break in the Varroa reproduction, and that will impact the population of Varroa. You can requeen a colony. Again, same idea. You're breaking that brood cycle, breaking the Varroa reproduction cycle so that you're helping that colony. Varroa screens. There's a lot of information that say that they're great, they're wonderful. I think that that's exaggerated, frankly. Varroa screens certainly help. It's not a solution, but some mites do fall down through there, and any mite that you can get out of that colony is one less you've got to worry about. So Varroa screens, I'm a big proponent of those, big advocate of those, because they do help. Hygienic bees, we hear about this often now. It's a hot topic in queen breeding. Certainly getting a queen that's got some hygienic behavior, the bees can actually sense a high number of mites under the capped, in the capped cell, and they will uncap it, remove the pupa, clean out the cell, and get rid of those mites. So hygienic bees. Drone trapping / varroa trapping, it's the same thing. This is a really great way to go, but if you were a procrastinator, not so much. I throw small cell foundation in there. The data doesn't support it, but a lot of people stand behind it, so it's something to consider. Drone trapping is one of my preferred methods because the colony is going to raise drones whether we like it or not. We know that the colony likes to have about 10% in this drone frame. This is a plastic frame. It's green in color, so it's easy to identify. You can put this in. This is all drone. You wait for most of it to be capped. The varroa is trapped underneath. You remove it. You freeze it. You wash it out, whatever you do. And you've just removed a substantial number of mites from your colony. But again, if you procrastinate and allow these drones to emerge, you are boosting your varroa population to numbers that you've never seen before. So make sure you get that frame out of there. And this is a very easy way to do it. It's not something that I recommend for beginners, but it works well. You basically have two colonies pushed together. You've got a queen excluder here that sits flat, so it forms a seal between these two boxes so that your queens can't jump from one side to the other. These are nuke migratory covers that when you remove it, your drone frame is right there, so you don't have to remove these honey supers. You pull this cover off, there's your frame, you swap it out with another one, and you do that about every 21 days. 21 days because it takes about 24 days for the drones for a queen to lay a drone egg and it to emerge out as an adult. And again, freeze those frames for 48 hours. It'll kill the drone. It'll kill the mites inside. You can keep them in your freezer. 21 days later, just swap it out. Just let it thaw out before popping it in there so it's not a popsicle. The bees work quite well in this system. The workers, the foragers, come in and go up to the supers. They go back to their hives. There's no major downside to this. It works quite well. Soft treatments, I'm not going to go over these too much. Again, I don't want to turn this into a varroa talk, but these are the soft treatments with some pictures. You've got nutrition as a major issue for colony health. And it sort of takes me by surprise that we spend so much time talking about nutrition because it seems fairly obvious. Right? If you think about your favorite food to eat, let's say it's pizza. You want to eat pizza. It's your favorite food. Well, if you eat your pizza day in and day out for a week straight, you're not going to be having a very well-rounded diet. You're not going to be getting all the nutrients and vitamins that you need. It'll supply many you need, but not all of them. So we need to have quality and variety of pollen. And this is more of a factor when we talk about commercial beekeepers that are bringing their hives into thousands upon thousands of acres of a monoculture, almonds, cucumbers, blueberries, apples, whatever the case may be, but they're only exposed to that very limited supply of one type of pollen, one type of nectar. However, when we think about sufficient food reserves, that's something that does impact us at sort of the backyard beekeeper, sideline beekeeper level, where our hives, we may not be moving them into these acres upon acres of a monoculture. We're keeping them stationary where we typically think they're going to have a well-rounded diet. They're going to be able to forage for dandelion, then poison ivy, then apple, then peaches, then clover, locust, whatever the case may be. They're going to hit a lot of different sources of nectar and pollen. But sufficient food reserves is really crucial. And this year is a perfect example. We had, here in North Carolina, we had a packaged bee day, and we sold off those packages. People took them home. And about a week after that day, we had a period of cool, rainy weather that lasted for about 2 weeks. Well, even colonies that had overwintered could not get out and forage. And those colonies that were started from packages had nothing stored up by that point. So if your colony that overwintered couldn't get out and forage, if your package that you started didn't have anything stored up, in both cases those colonies either are lacking reserves or they're void of reserves altogether. So you've got an example of poor nutrition, a case of poor nutrition. Those bees are struggling. Those bees are not only are the adult bees impacted, but future generations are impacted, because the frames at the onset of tonight's presentation that I showed you that had the pollen, that had the honey, those resources, that pollen, that honey that's on the in the upper corners where they're raising the brood, it's put there because they need those resources to feed the developing larvae, to make their brood food. So not only do the adult bees, of course, need food, but the developing larvae need food. And they use those resources to create that brood food to feed the larvae. So if you have a case of poor nutrition, of course the overall health of the adult bees are going to be impacted, but the next generation is impacted as well because they had poor nutrition essentially as a child, as a developing bee. And so they are impacted. And there's some researchers out there that argue that yet the next generation is impacted as well, because now, right, the second generation, which was larvae under this malnourished colony conditions, now that they're adult bees, they are still inferior bees now that are mixing up this brood food that they're feeding to what will be the third generation of adult bees in that colony. And so there's some that argue we see this sort of delayed or impact to the colony 3 generations from the time at which we actually have conditions of malnourishment. So this is really something that we need to look at. And typically it's not a problem, but if your colony goes into a dearth and they exhaust their resources, you need to be concerned, because a lot of dearths happen later in the season, July for us here in North Carolina into August, and if it's impacting potentially 3 generations later, that's getting close to those bees that we want to overwinter. And so if they're not 100% healthy because of malnourishment that happened a few months earlier, we can't expect them to survive winter. So nutrition is imperative. And some of the data supports that. Colonies with Varroa tend to have poor nutrition. So again, this ties back into maintaining our Varroa at a low level. And if we look at colonies that have great nutrition, they are able to deal with Varroa just as well as colonies with they are able to deal with colonies with high Varroa levels. Sorry about that, stuttering on this one. Colonies with high Varroa but have good nutrition are able to be just as healthy as colonies with low Varroa but poor nutrition. So good nutrition has some ability to overcome the effects of Varroa. So we've got to keep an eye on that. We've got to make sure they're not exhausting their reserves. We also see that good nutrition helps us with resistance to nosema, pesticides, and viruses. That was done by Zachary Wong in 2012. So nutrition is imperative, and it's something that we often overlook. We often think, well, it's springtime, there's a nectar flow, things are good. Well, it was springtime this past year, but it was 2 weeks of cold, rainy weather, and things were not good. And colonies are still paying the price for it now. So we've got to be mindful of nutrition. The third factor that we mentioned earlier on was contaminants. So let's talk about that for a second. You may have heard the analogy that the wax in a colony serves as the liver of the hive. It's a filter. It's where things get absorbed into. So what's getting absorbed into this wax that may be a problem for us? Well, mite treatments, both legal and illegal, are getting in there. So things like fluvalinate from Apistan, Coumaphos from Czech mite. These things are present in the wax inside our colonies. Environmental contaminants. So our bees leave our hive, and once they do, we have no control over where they go. They're going to our neighbor's yard that maybe just was sprayed for dandelions, so they don't have weeds in their yard, or clover in their yard. They're traveling to the peach orchard that's right down the road that may have just sprayed, and they're picking up those contaminants, those sprays in those environments and bringing them back to the hive. So these things we can't control directly. We can't necessarily control what our neighbors do. We can't necessarily control what the orchardist down the road does, or the farmer or the small little backyard gardener that just sprinkled Sevin dust on some of their vegetables so that they don't have pests in their garden. We can't control that, but yet these things are making their way back to the colony. And in fact, there was a great study done back in 2010 where they collected 887 samples. They found 121 different pesticides, or the metabolites. In other words, the things that these pesticides break down into. 121 different things. 14 of them were systemics. In other words, these are pesticides that are applied to the seeds when they're planted and get incorporated into the plant tissue as the plant grows and are present in the nectar and or pollen of those plants that our bees are foraging on. 14 of those. 60%, more than half of the pollen and wax samples had at least one, and the average was, I think, 6.1 different pesticides per sample. So let's look at this for a second. Now this is a graph that I snagged from Marianne Fraser and Jim Fraser when they were here a few years ago. They used this slide in their talk because they're the ones that do a lot of this pesticide work. Here's an example of Assail and Nova, which are two pesticides. And real quick, if we look across this bottom, well, first off, Assail is the square, Nova the red triangle, and then the combination, the green diamond. If we look across this, you can see the parts per million for Assail and Nova goes straight across. It's benign, essentially. The bees can drink it almost like water. It doesn't have an impact on them. But yet when you combine them together, and I should mention that Assail is an insecticide used in a lot of apples and blueberries and things like that, and Nova is a fungicide that is used in similar crops. So very possible to see them in combination. When you combine them, look at what happens. It's nearly 90, let's see, what is this? Not quite 90% lethal at the highest concentrations where they're combined. And yet these concentrations are still lower than the concentrations where they're separate. Okay? It's basically this middle range right here where they were benign. Now, at those concentrations, they are nearly 90% lethal. So these things, let me jump back here, these 121 pesticides that are making their way back to their colony, into our colonies, by themselves may be perfectly benign. And when the chemical companies test them, they test their product. They test their product to see if it's safe for honeybees. And oftentimes, as we just saw, they are. They're virtually benign. They can drink it like water. But what is not tested, and which is very difficult, frankly, from the chemical company standpoint, to test against all the possible combinations that exist out there. They're too vast to test every single combination, but yet we know, and this is a good example, that when these things come together in combination with one another, it becomes a very, very lethal combination. And so what can we do as beekeepers? Well, comb rotation. Researchers for years now have been talking about culling old comb. Every 3 to 5 years, rotate out your old comb. Now that doesn't mean on year 3 you take all your frames, you throw them out, or if you prefer year 5 you take them all, throw them out. No, what it means, the best way in my opinion to do it, is every year cull a third or a fifth, if you want to do it on a 3-year cycle, a third of your oldest comb. If you want to do it on a 5-year cycle, a fifth of your oldest comb. And what happens is you do that every year, and essentially after 3 years or 5 years or 4 years, whatever you want to do, you've rotated 100% of your comb. So at no point is there a frame which is older than 3 years or older than 5 years in your colony. And so these contaminants are not accumulating to such high levels. And here's a frame that's just really ripe, really prime for being culled. You know, it's missing a huge portion of comb, probably because a mouse may have gotten in here and chewed a portion of it out. You can see all this propolis. You can see that there's a lot of some drone down here. They're building drone here. Just not a very nice looking frame. This might be one to cull. And the way that I like to do it, and this is ideal if you've got medium boxes, all medium boxes for your brood chamber, for your honey supers, everything. Let me explain the graph here, the schematics that I've got here. So these dark gray bars, these down in here, sort of scattered throughout, randomly scattered throughout, are comb that I want to replace. It may be my oldest comb, it may be a frame like that I just showed you, all ratty looking, and that these white bars are good comb. And these orange ones are frames of honey, or frames that I would use in a honey super. Now this scenario, the schematic assumes that all these boxes are the same size. In other words, they're all, in my case, all medium boxes. And I'm also using 8 frame boxes, but you can imagine this with 10 frame equipment. It doesn't much matter. So I run 3 mediums for my brood chamber. And I've got 8 frames here, which is a third of these old frames that I want to cull out. And so I've got these these 3 boxes stacked on top with 8 frames per box, and I want to cull roughly a third out of them. And I've got my medium super, and I've got my honey frames here, and I'm collecting honey during the spring and summer. And I overwinter. But now what I do before going into winter is I try and position all these frames that I want to get rid of to the outside of the box, and if I can, I try and concentrate them down into the lower stories. Why is that? Well, the reason for that is if you've kept bees for a period of time, you know that the bees in spring are typically found up in this top box. So if we concentrate the frames we want to get rid of to the bottom, come springtime, we can easily remove those frames without worrying about removing brood. And we don't want to sacrifice the growth of the colony in springtime. We want to do everything we can to get them growing, to get their numbers increasing, to get that colony ready for a nectar flow, get them healthy, get them recovered from winter. And so we don't want to take brood. So the bees are found typically up here, so we can take these frames from down below without taking brood. And they're typically raising brood in the center of the box. And so if we position our frames to the outside, again, we reduce the chances that we're going to be stealing brood from this colony, that we're going to be compromising the growth. And then again, to ensure that this colony can continue to thrive and grow under conditions that still may be kind of stressful, because we're still kind of in like maybe March or April, where temperature fluctuations are running amok. There are highs, there's lows, there's clustering, there's breaking of the cluster. We've got stress in that regard. Maybe a good strong flow hasn't come on just yet, so nutrition may still be a factor. We don't want to compromise the growth of this colony by putting in fresh foundation that we're forcing this colony then to invest resources in drawing that comb. We want to give them every asset they can to continue to grow unimpeded. And so the way I do that is I steal frames, drawn comb, from my now empty honey frames. I've extracted that honey. It's comb that's drawn but doesn't have honey in it. And I replace the frames that I culled with these frames that are already drawn out. Now, this allows them to jump on that comb. It's drawn. They can start utilizing it virtually immediately, storing nectar, storing pollen, raising brood, whatever the case may be. It's ready for them to utilize. And but it's drawn, but it's not necessarily contaminated to the degree that the brood frames are contaminated, because that's where they're storing most of the pollen, right? And that's where a lot of the contaminants are coming from. They're storing the pollen, they're raising the brood, that's where our contaminants are concentrated. Yes, there still may be some in these honey frames, but not nearly as high as down in the brood chamber. So I'm giving them relatively clean comb to work with, and they can begin working it immediately. And I'm not compromising the growth. And if I do things right, this colony then will be strong enough to draw out any fresh foundation that I put back into my honey supers, no problem, because the colony numbers will be strong, because I've done everything I can to grow that colony in spring. The last thing we need to consider is queen quality, right? She is ultimately responsible for the population in that hive, the genetics of that hive, therefore their ability to deal with nectar dearths, with pollen dearths, with disease or pests. Ultimately, it goes back to the queen. So queen quality is imperative. So what makes a good queen? Of course, disease resistance, right? We want to make sure that she's got some good genetics and resistance to the various diseases that are out there. But we need to couple that with some other things. Of course, we need them to produce honey. They need to produce honey not only for themselves, but most of us tuning in here this evening want honey for us as well. So they need to be able to produce honey. They need to overwinter well. So we need some good genetics here. We need some good overwintering traits. And all of this stems back to the quality of rearing, the quality of raising those queens. And if we look at this schematic here, we can see royal jelly aplenty in these clear cells that are raising out queens. Good source of royal jelly. This is not only attributed to the abundance of resources, but also good, young, healthy nurse bees that have really active hypopharyngeal glands that produce this royal jelly that are fed to the queens. So you've got to have good quality of rearing those queens and a good quality of mating. We know research is well substantiated that a good quality mated queen will have a good quality healthy hive, healthier hive. They can better adapt to temperature changes. They can better adapt to disease. They can better adapt to resource availability. So you need to have good quality mating. So how do you achieve that? Well, if you're trying to do that yourself, you need to be aware of what it takes to raise out a good queen, to rear a good queen, having those young, healthy bees, nurse bees, with a good source of nutrition to develop that royal jelly. You need to have some good drone saturation in your area. And this is where small regional queen rearing operations can thrive. Do it with a club. Do it with a group of friends. Share queens. Choose the best from your various operations and graft from them and spread them around so that you're creating a situation in your local area where, one, you've got locally adapted queens, and two, you've got good mating conditions for those queens when you're rearing them. It's difficult for a backyard beekeeper that's only got 1 or 2 hives to raise out good quality queens when they've only got 2 or 3 hives to select from, to create the mating nukes and the cell builders and all those other things. But if you start to cooperate and collaborate with other beekeepers in the area, now you can pool your resources, and it lowers the threshold and the equipment requirements, the bee requirements, and makes it much easier, and you all benefit. So good quality queens are imperative for a good, healthy hive. So ultimately what it boils down to is we've got to be proactive in our management for diseases and pests. We need to ensure that they've got a varied diet, but for most of us tuning in, it's not about a varied diet as much as it is being in tune with conditions in nature, with our weather, that may impact our bees' ability to get to that varied diet. The examples that I gave earlier about the cool, rainy weather are prime examples of how we need to be in tune with what's going on so that when those conditions present themselves, we can take action to feed. This isn't an issue of beekeepers necessarily stealing too much honey, which I hear often. Well, they took too much honey, therefore the colony starved. This is simply Mother Nature throwing a curveball and creating conditions where the bees just simply can't get to enough resources to have a good, well-nourished diet. A clean hive, those contaminants that we talked about. It helps not only with those chemicals, but it also helps with disease, things like nosema, foul brood, etc. It just makes good sense to cull that older, tainted equipment. Quality of the queen. A good quality queen translates into good quality bees that are better able to deal with the above issues, the contaminants, the nutrition, the diseases, etc. So a good quality queen. If you can take care of these 4 things, it's easy, right? If you can take care of these 4 things, or at least take steps to move in the direction of mitigating some of these factors, you will have a healthier hive for it. So with that concludes this evening. So let's take a quick look at our questions panel. We have a few minutes here this evening for questions. So let me pull up my panel here and see what we've got. If you'd like to ask a question, I see that there's numerous questions already, but there should be a question panel to the right of your screen. You can just type it in there. I'll read your question aloud and do my best to answer it. I don't have all the answers by a long shot, but we'll see if we can't come up with some responses here for most of them. So we talked about Varroa levels and trying to assess what that population is. The question is, how do you calculate basically the Varroa count using the IPM sheet? For those of you that don't have one of Brushy Mountain's screened bottom boards, it comes with a sheet that has a grid pattern on it. Basically, to get your Varroa levels, what I suggest is, you're at your hive, you're probably doing some inspections, maybe checking for the brood pattern, maybe checking for some other diseases, maybe you're checking to see if you need to add a super, whatever the case may be. You're probably doing some inspections. Well, that disturbance creates an artificial spike in the mites that fall off the bees. And so what I suggest is do your inspection, slip that sheet, that gridded sheet, into the screened bottom board, and wait 3 days. And that way, that artificial spike in the Varroa drop is sort of washed out by the fact that you're collecting 3 days worth of mite drops. You'll sort of get a good average. So you take that sheet out after 3 days. You have to count every single mite on the sheet. That's why it's gridded, so that it makes it a little easier to know where you've counted and where you haven't. But you count every single mite on that sheet in the grid pattern and divide it by 3, because those numbers are for a 24-hour mite drop. Well, you've left it in for 3 days, so divide it by 3. That gives you a 24-hour mite drop and gives you your mite levels. So that's how you use that. So here's a question about hive beetles. And before the presentation started this evening, I had a question about which is worse in the south, hive beetles, small hive beetles, or varroa mites. I responded, I think it's the varroa mites. A quick comment on small hive beetles. Their numbers certainly are increasing in the past few years, and they are becoming more prevalent, more of an issue, more of a concern. However, for the most part, and there are some exceptions to this, there's exceptions to everything, but for the most part, I still consider small hive beetle an opportunistic pest, much like wax moth, where they exploit colonies that are struggling for some other reason. So the beetles rarely are the direct cause of a colony dying out, but rather a symptom of some other problem. Maybe it's a failing queen. Maybe it's varroa. Maybe it's the viruses. Maybe it's poor nutrition. Whatever the case may be, they seem to thrive and take hold in colonies that have some other problem. And so if you have, now I should clarify here that I'm willing to bet that I could go through the colonies here at the bee farm and the colonies that I've got in my backyard, and I'm willing to bet that almost every single one of them has hive beetles in it. Now, that's not to say that every single one of those colonies has a problem, because you will find hive beetles in your colonies, but that does not mean that they're a problem. The bees will protect themselves. They will attempt to quarantine those beetles. They literally try to put them in jail by building a propolis jail, by cornering them and creating a seal with propolis. What happens is we mess it up. As beekeepers, we come along, we crack the inner cover, we open it up, we create a disruption, the beetles scatter, the bees scatter, and now their attempts to quarantine them, to confine them, has been thwarted by us. And what happens? We see the beetles and we panic. We think, oh my gosh, we've got a beetle problem. There's beetles. That's a problem. And in some cases it may be, but in most cases it's not. You can put in a beetle trap, those little traps that you fill with a little bit of mineral oil or something to trap those beetles. If you see gobs and gobs of beetles, yes, maybe you've got a problem. But typically you're going to see some beetles that are getting chased into those traps, and it's not really an issue. So that's my comments on beetles. But the actual question that's being asked here is, how long will an area remain infested with beetles after the hives in the yard are moved to another location? Well, the sad truth is that beetles, small hive beetles, are tremendous flyers. They can fly up to 15 miles. And so if you move your colonies out of an area that you've got beetles, you treat for the beetles, and let's just say you're able to kill 100% of the beetles in there, you move them out to an area that you think to be beetle-free, the fact of the matter is that there's probably someone within 15 miles of you that has bees that also has beetles, and those beetles are going to come back. But keep in mind that they're opportunistic generally, and not the cause for a lot of the problem. They're a symptom of a lot of problems. So hopefully that helps. Let's see here. So let's see. there's been an indication of pesticide buildup in frames and wax in hives. Should we replace frames and foundation on a rollover schedule? Yes, that gets to the 3 to 5 year cycle. Trying to cull a third to a fifth of your frames, depending on what your cycle is, would depend on how often and how many frames you cull out. So here's a question about how many times a year should I treat for mites? That's a difficult one. A lot depends on that level, what your mite levels are, but I've sort of come to the realization that if you've got an opportunity to treat, take it. Now, I do want to clarify what I mean by treat, because a lot of people, when they hear treat your hive, immediately assume putting in some sort of either hard or soft chemical. And that is sort of the historical definition of treating. I broaden my definition of treating to include things like the drone trapping, which isn't really, by the definition, a treatment, but it is a means to keep your mite levels low. You can do things like powdered sugar, which has become more accepted as a treatment, but still by many is not considered a treatment. It's considered just something that keeps your mites low. So you can do things like that that are simple, that are easy, that you can do throughout the year to keep your mites low. And if we think back to that graph where the bee population was growing and the mite population growing exponentially but offset slightly in time, if we can somehow prevent that exponential growth of the mite population, we're therefore preventing the exponential growth of the virus infestation as well. And so anything you can do to interrupt that growth is going to be an asset for you. And so I joked, with this slide that I've got up here currently, that all we've got to do are these 4 things. It's easy, right? We'll have good, healthy hives. Well, of course, it's easier said than done. And I mentioned that we need to take steps to move in this direction. Well, doing something like drone trapping, doing something like powdered sugar would be an asset and would move us in the direction of trying to be proactive for these diseases and pests. So how many times a year? That's difficult to say. It depends on what you're doing. But the long or the short is, if you've got an opportunity, take it. Another example, I'm getting ready to pull honey now, hopefully this weekend, pull the spring honey off my hives and the hives here at work in preparation of what I hope to be a sourwood flow here in the next few weeks. I'm going to use that opportunity to throw on some Mite Away quick strips, which are approved during a honey flow that I can use during this time of year to try and knock my mite population down. So you can do things like that. You just have to be aware that can be, formic acid's a touchy one in hot weather, so you have to be careful there. As no sooner do I finish that statement that the next question is, what are your suggestions for addressing varroa in areas where summer temperatures in July and August are higher than 90 to 100 degrees, making most treatments unusable? And that's particularly important with the essential oils or organic acids, which rely on evaporation. Of course, the higher the temperature, the faster, the more vigorous the evaporation, therefore the higher the dose right at the beginning. And that can be a concern, as I just alluded to. So what are your options? Going back to things like integrated pest management, powdered sugar, drone trapping, etc. The problem with drone trapping historically has been that it's labor intensive. Well, that setup that I showed you with the 2 hives and the super stacked up in the middle of it, that can be something that lessens the labor involved because you don't have to unstack those honey supers. Makes it a little bit easier to do with the drone trapping. So you can do things like that. You can also, I should say this, that as a equipment supplier, I'm obligated to say the label is the law. That if you're using these products, any sort of miticide, whether it be the soft chemicals or the hard chemicals, the label is the law, and you should follow that. However, what a lot of people do, and what someone recommended to me with the Mite Away Quick Strips, which is very temperature sensitive, is they don't give it a full treatment this time of year. They may only throw on one strip out of the two that are required for the treatment, or they may only use a half a strip. And beyond that, they may, if they've got a bee yard of 20 hives, they may go and put the strips on the outside of the telescoping tops, and they go down the line, and then they go back to the beginning and then actually apply the treatments to the hive. And what that does is you put the strip on the hot cover, and that initial burst of formic is released by that, because it's now baking essentially out in the sun, right, and evaporating. And that and right at the beginning is where you get the most flush, most evaporation of formic acid. So you you remove that from the hive by putting it on your cover. And so you get that initial flush of formic out of the strip before applying it to your hive. Now again, as someone that sells this product and distributes this product, I'm obligated to say the label is the law. This is just what people have communicated to me, but hopefully that information is valuable to you. When do you recommend a final harvest in preparation for treatment of the honey buildup for winter hive? This depends tremendously on your particular area. Here where we are, we don't get a whole lot of goldenrod. We get a little bit of goldenrod, a little bit of aster, which is sort of most places sort of the end of the season in terms of nectar flow. So I have to make sure that when I do my harvest of sourwood, if by chance I get any, that I have enough in that hive at the end of mid-July to end of July to last me the season, because I can't bank on the goldenrod flow. And so I've got to be careful how much I take then and how much I'll take this weekend of spring honey, because I need to make sure I've got about 60 to 80 pounds to go through winter. And oftentimes I end up feeding because it's hard to project how much I'll have in August based on what I have in there now. So that's a difficult one to answer. But typically, I try and do my harvest in July, and that leaves anything that they are able to produce in August and September for their winter feed. It also allows me to get some treatment on there in advance, so that I get a couple of generations of bees being reared under low mite conditions. So I'm doing two things. I'm hopefully maximizing on their reserves, their nectar and pollen reserves going into winter, and I'm also maximizing on the health by treating earlier and allowing them to raise out future generations. So my recommendation for treatments, and oftentimes the treatment is just after the last harvest, is late August, early September, depending on where you are. If you're further north, more so on the August time frame. If you're further in the south, then you can maybe push it into September a little bit. So hopefully that answers that question. And let's see. Here's a question about a dearth, and we're past our 7 o'clock mark, so I'll make this our last one. How do you determine when there's a dearth? When you should feed pollen or syrup during a dearth, or should you feed pollen or syrup during a dearth? Well, basically, you have to be aware of whether your colony is putting up or consuming pollen and or nectar. And so this requires going in and looking at frames. Right now, I can go in and I've got honey supers on. And so I can go in and look at those frames of draw and comb and look to see, are they storing nectar? Because when I put those frames on, when I put those supers on the hives, those frames were empty, had nothing, no nectar, no honey, nothing. And so if I'm seeing nectar in there, that means they're gaining, they're putting up a surplus. And so it may not be a great flow, but at least there's something. And that's pretty much the scenario we've got right now. It's not a great flow, but there's something. So you've got to monitor sort of the net gain or loss of your hive. Are they consuming or are they storing? So that takes inspections. And should you feed during a dearth? That gets back to what are their reserves. Let's say they had a tremendous spring flow and they've got stored honey, stored pollen in that hive, but now I don't harvest it. For example, let's say I choose not to extract this weekend and I'll leave the honey on the hive, and we get a dearth in July. Well, if they've got reserves, stored reserves, I'm not necessarily going to jump on the feed, but I also have to make sure I do start feeding before they exhaust what they've got stored, because I don't want them to go into that state of being malnourished. And so at that point, if I see that they're continuing to consume their stores, their reserves, and it looks like they may exhaust them, I will be proactive and I will start feeding syrup, and I will start feeding a pollen substitute. So hopefully that answers your questions. There are numerous other questions here. I apologize for not getting to them all. Please feel free to reach out to us, shoot us an email, give us a call, chat with us online, whatever your preferred method. We'll do our best to get your questions answered. We want you to have the information. This is important stuff, so please feel free to reach out to us. We want to make sure you've got it and that you do well and give you every opportunity for success. So thanks for tuning in this evening. Hopefully you found this information beneficial. We'll look forward to seeing you next time. Until then, have a wonderful evening, have a great season, and produce lots of honey. Thanks a lot. Have a good night. Bye-bye.